Okay, we're going to look at a new topic, which is going to be angle properties of circles. Okay, now the first thing that we're going to do is to sketch out a circle, and it's not bad, but let me just rub this bit out. Okay, and we're going to explore some of the properties of a circle and its angles. Okay, the first thing that we're going to do is put in a centre spot. Okay, now if I draw a line from here to here, we would agree that that is the radius. Now what I'm going to do now is to draw a tangent to that radius. Now a tangent is a straight line that has one point of contact with a shape. So in this situation here, it's a circle. Now something that's a law, that's definitely true, is that the radius and the tangent will meet at a right angle. So that's one thing that we can say straight off. Okay, what else can we say is true? Well, if I was to draw a triangle in here in the circle, then that would definitely be an isosceles triangle, meaning that two sides and two angles are the same, and the two sides would be these ones. Now, why do we know that's true? Well, we would need to agree that from the centre spot to here must be the radius. But if that's true, then from here to here must also be the radius, because that's also from the centre spot to the circular edge. Now what that must mean then is that that length and that length, if they're both the radius, that means they're both the same length, and if they're both the same length, that means it is an isosceles triangle, which means that this angle must be equal to this angle. So if this angle, for example, was x, then that angle would also need to be x, it would need to be the same. Okay, another point to note is if we took this circle and we split it down the middle so that we've got two semicircles, well, I'm going to concentrate on this semicircle here. If I then mark a point anywhere at all, so anywhere on the circle between here and here, so in this semicircular part, if I mark a point anywhere on the circle, so I'm going to mark it here. And then what I'm going to do is to join these up. What we'll always get is a right angle at the point we marked on the circle, and that's always a law as well. So any triangle that lies within this semicircular part of the circle, where we're on the circle here, here and here, that is always going to be a right angled triangle. So for example, if I was to draw a semicircle here and then to draw a triangle within it, the question wouldn't tell me that that's a right angle triangle, but that is definitely a right angle triangle, because it's always a right angle triangle when we've got a triangle within a semicircle. So here's another one, that's a right angle, and there's another one, that is always a right angle. So the question won't tell you it's a right angle, but it's definitely at all times a right angle triangle. Okay, so let's try a couple of examples where we need to find a missing angle. Okay, so example 1. Let's put a triangle in this circle like so. We're going to say that this angle here is 130 degrees, and the target is to work out this angle here. Now, a good approach to take with these questions is something that's called a goal-free approach. Now, what it means is don't think too much about your starting point, just start to find missing angles and take it from there. Now, the first thing that I can do is I can work out that small angle in there, because I know a full turn is 360 degrees. I'm going to just change that to 330. So we know that a full turn is 360 degrees. Now I know that this part of it, this bigger angle, this bigger reflex angle is 330 degrees, which means I can find that smaller bit out. So remember that the full turn is 360, and this part is 330, so to get that smaller angle in there, it would be 360 take away 330, and that smaller angle then is 30 degrees, so I'm going to put that in. Now the next thing that I know is that this length here is the radius, and this length here is also the radius, which means these two angles must be the same, so both of them would be marked as x then. So next thing, I know that three angles in a triangle add up to 180. So if I do 180 take away 30, that's 150. So I know that both of these angles then must add up to 150. Now the other thing that I know is that they're both the radius, since they both come from the centre of the circle and hit the outer edge. So if that's the radius, that's also the radius. They've got the same length, which means these angles are the same. They both add up to 150, they're both the same, which means one of them is just 150 divided by 2, and that's 75 degrees. Final answer. Let's try an example 2. Okay, so we've got a circle again. Okay, this time I've got a diameter that runs through the circle, and the line of the diameter extends with a straight line there, and I'm told that that's 140 degrees, and I'm asked to find this angle, which is x. So again, a goal-free approach means I'm not going to think too much about the several steps I need to make. I'm just going to start somewhere. Well, what's the first thing that I could do? Well, I could work out this smaller angle in here. Now, I know that that is a straight angle, that's 180 degrees. So if that's 180 degrees, to get the smaller angle in there, I would just take the 140 from the 180. That means that that angle in there, the smaller angle, is 40 degrees. I also know that that must be a right angle, since any triangle inside the semicircle will be a right angle triangle. So I know that that's definitely right angled. Now I've got 40 and 90, so I can just add them both together to get 130, and then I just take those two combined, 130 away from 180, because three angles in a triangle add up to 180, and I get a final answer of 50 degrees. Okay, quick point to note is there's more than one way of doing these questions often. Okay, next one. I've got a triangle like so inside the circle. Okay, and I've also got another triangle there. Okay, I'm told that this angle here is 310 degrees, and the target is to find this shaded angle, which I'm going to call x degrees. So again, this kind of goal-free approach. What angle could I work out? First of all, it looks like I could get that one in there. Remember that the full turn is 360, so if I call that angle y, well, that will be the full turn of 360 take away 310, and that is 50 degrees. Okay, now if that's 50 degrees, I could now work out these two. Now, what do I know about these two? Well, I know that they're both radius, so that's an isosceles triangle. Remember that the three angles of the triangle add up to 180, so if I do 180 take away 50, I get 130, so I know that both of these angles then must add up to 130. They're both also the same, so to get one of them, I would just divide that by 2, and that will give me 65 degrees, so that angle in there is 65 degrees. Now the next thing that I know is that law that we explained earlier, the radius and the tangent will meet at a right angle. So that angle there is definitely a right angle. Now this part of it is 65 degrees. So to get that part of it, I would just do 90, take away 65, and that angle in there then, x degrees, is 35 degrees. Okay, let's try one final example. So I've got another circle, and there's a centre spot, so a triangle within that circle. We've then got another triangle that extends as a straight line. Okay, now I'm told that this angle here is 110 degrees, and the target is to find this shaded angle x degrees. Okay, so a goal-free approach again just means that I've not got a set place to start, but I'm just going to start to try and work things out as I go, in the hope that that will eventually take me to the correct answer. So what could I do first here? Well, I could get this angle in here. I know that that's a straight angle, and we know that a straight angle is 180 degrees. So if I call that angle then Q, then Q degrees would be the straight angle, 180 minus the 110. And that then is 70 degrees. So that angle in there is 70 degrees. Okay, now if that angle is 70 degrees, that angle is also 70 degrees, because that's a radius and that's a radius. Okay, now if that's 70 degrees, what I also know is that the radius and the tangent will meet at 90 degrees. So that's a 90-degree angle, which means that smaller angle in there must be 20 degrees, because it's just 90 take away 70. Okay, next thing, I know that the three angles of the triangle add up to 180 degrees. So I could do 110 plus 20 is 130. And then to get x degrees, it would be 180 take away 130. And x degrees then is 50 degrees. That's an example where there's more than one way to do it, but that's definitely a good way to get the final answer, 50 degrees.